That's another good subject for a term paper, is any one of these ideas. And habitat loss is another problem for amphibians. And you can see that yourself. I mean, just look, anytime construction is going on, if there's a wetland, that wetland is getting filled. Amphibians, by and large, are reliant on wetlands. They either live in the wetlands all the time, or they need that water in order to lay their eggs. You destroy that habitat, remove that habitat, then there's no place for that animal to live. So every time we build shopping centers and highways and things along those lines, we're reducing the amount of habitat, which then reduces the number of amphibians in the general area. So it is a worldwide problem. You have a decline in numbers, you have a decline in the diversity of amphibians, and there are multiple reasons for that. And unfortunately, they're all human related. Questions? All right. Okay, we'll start on reptiles. We look at the classical taxonomy for these animals. What's in your course pack? We're going to be dealing with the class Reptilia. Subclass Anapsida. Which contains the order Chelonia. Who's Chelonia? Yeah, turtles. So anybody that did actually look at them the Wednesday before break. Subclass Archosauria. And among our living amphibians, reptiles, it's the order Crocodilia. So our alligators, crocodiles, caimans are in that particular order. And then subclass Lepidosauria. With the order Squamata in it. Underneath that order, we're going to have 3 suborders. And Spinodontia. Lacertilia. And Ophidia. So I'm just putting these up here because I'm going to use them at various times during lectures, so you need to know it. You need to know it from that as well. All right, so the Chelonia are the turtles. Crocodiles and their relatives are in the Crocodilia. Everybody else, as far as reptiles, classical classification, are in the order Squamata. Suborder Spinodontia, that has the animal that's called Spinodon, that's the genus. Common name is the Tuatara. Lacertilia, this is going to be your lizards, and Ophidia are the snakes. In order to talk, where will I start with reptiles? I'm going to start the same place I did with the amphibians and look at reproductive patterns. So we're going to look at reproductive patterns in the reptiles and make some comparisons with the amphibians.
What's this one?
So there are some fundamental differences between the way amphibians and reptiles reproduce. Amphibians have a moderate amount of yolk. Compared to fish, they tend to have more yolk in their eggs, but compared to a reptile, it's only a moderate amount. So in general, reptiles are going to have more yolk in their eggs than an amphibian. There's a short developmental period for an amphibian in the egg relative to that which occurs in a reptile. So reptiles are going to spend a lot more developmental time in the egg than an amphibian. In general, an amphibian is going to lay the eggs in the water, and reptiles are always going to lay them on land. There are no exceptions. Most amphibians are going to have this free-living aquatic larval form, or tadpoles. Reptiles never have a larval form. And many of these things are connected to each other. So if you're going to be spending more time in the egg, you need more yolk. If you're not going to have this free-living aquatic larval stage in which you continue your development, and in that free-living aquatic larval stage you're eating and getting your own energy, if you're going to accomplish all your developmental changes while you're in the egg, you need more yolk in order to fuel all of those changes that are taking place. So many of these differences are just simply explained by the fact that the reptile will spend more time in the egg. In addition, there's a structural difference in the egg of these animals, so that amphibians have one extra embryonic membrane. One extra embryonic membrane, whereas reptiles, and in fact, reptiles, birds, mammals, have 4. Okay, what do we mean by extra embryonic? Extra in this case just means that it's outside of the embryo. All right, so it's a membrane that is outside. In amphibians, fish as well, that single extra embryonic membrane is the yolk sac. And as the name implies, it encases the yolk. It is outside of the animal, but the blood supply is continuous. So in other words, the blood circulates through the embryo, but it also circulates through the yolk sac. And that's because the yolk sac is going to release digestive enzymes that break down that yolk into your simpler molecules. Those are then transported by the blood into the embryo and fuel its growth and development. Reptiles and birds and mammals are going to add chorion, amnion, and allantois. So they have 4 extra embryonic membranes. And in general, we call the reptiles, the birds, and the mammals the amniotes, as opposed to the fish and amphibians, which are amniotes. An here is meaning without. Okay, how are these things arranged in the egg? There's our embryo. The first of the membranes that will form in an amniote, like a reptile, is going to be that yolk sac. And will actually come out. So it's attached to the animal. Inside is the yolk. So the membrane around the outside is the yolk sac. The yolk sac contains the yolk of the egg. The amnion and the chorion are the next ones to form. And it's really hard to show this in 2 dimensions. But they'll come out something like this. Same thing on this side. So it's going to grow out from the animal as one membrane. And it's going to wrap up and back over the top of the animal, and it will actually join right here. So it's a single membrane in 3 dimensions. It's coming out and it's going back up and over the dorsal part of the embryo, and when it makes contact, it fuses. That then gives you 2 separate membranes. The outer one here is the chorion. Note that we have that one right there surrounding the embryo. So if I put my hash marks in there, the cavity, the space inside of the amnion, so between the amnion and the embryo, that is the amniotic cavity. That amnion holds the embryo in a watery environment. So that amniotic cavity is filled with a watery fluid. It's the same amnion. It's homologous to the amnion in humans. Amniocentesis, they just go in with a needle, they extract some of the fluid from there and look at the cells that are in there, or the chemical composition. The allantois, yeah?
Does it close at the bottom too?
No, it does not. No. The allantois comes out, actually my eye should be there, something like this. So that's the allantois. It's an outgrowth, a continuation of the cloaca of the animal. Remember, cloaca is a sewer. It's that lower part through which the digestive products, reproductive products, and urinary products all pass. Allantois is highly vascularized as well. It has a couple of functions. One is it is going to receive the nitrogenous waste that is produced by that developing embryo. So these eggs are they're going to be covered by a shell. And so you're producing waste materials, and somehow you have to store that waste material or detoxify it. What amniotic eggs have is a storage place. So the material comes out of the animal and passes into the allantois. We're storing our nitrogenous waste in here. And at the time of hatching, that detaches and is just left behind in the egg. So the developing animal inside the egg is not spending any energy on detoxifying those compounds